just going to go through an alternative solution for 9 part 4 because it's a really difficult question. It's currently the most watch of the videos that I've done, and it's one of the nastiest questions I've seen on a C3 paper. So I'm going to start off the same way as we did before. We need to find g of f of x, which is going to be less than 5, we're told. And g of f of x is where we take f of x, and where we see x, replace f of x, or replace that x with the f of x. So g of f of x is going to be a, which we know is now just minus 1, so we're going to have minus 4x squared minus 12x, and then plus b. So that's our g of f of x, and we're told that that's less than 5. So if I just expand these brackets, just get rid of the brackets there, and also take away that 5 like I did before, then we're told that this quadratic here needs to always stay negative. It needs to always be below 0. If we think of that graphically, that means we've got this kind of shape going on, where the graph just at some stays below the x-axis, so it never has any solutions. And we know that if a graph doesn't have any solutions, then its discriminant will be negative. So we know that the discriminant of this quadratic here must be negative. Since there are no solutions. So if we work out the discriminant, which will be b squared, so 144 minus 4 lots of a, which is negative 4, and c, which is b take 5, because we have no solutions, that needs to be negative. And if we simplify this, if we calculate what this is equal to, that's going to be plus 16 lots of b take 5, which is 144 plus 16 lots of b, take away 80. And if we simplify this, that gives me 64 plus 16b must stay negative. Couple more steps, just move the 64 to the other side, and divide by 16 tells me that b has to stay less than negative 4. You could also, at this point, I know lots of us don't like negative quadratics, is you could have made this bit, we could have times both sides by negative 1, and when doing that, remembering to switch this to a greater than 0. But all that would have done is would have given us a positive quadratic that needs to stay above 0, like this, and therefore the discriminant of the negative version, which would be positive 4x squared, take away 12x, take away b plus 5, needs to stay greater than 0, and we would still need to find the discriminant of this and show and work out b for when the discriminant is less than 0, because there's still no solutions. This is still not crossing the x-axis, and you would end up with what we had here before, like before, b is less than negative 4. So you could go down this route, but you'd end up with the exact same setup. You would end up at this point here with 64b plus 16b is less than 0, or negative 64 take away 16b is less than 0, and therefore it still gives us b is less than negative 4. I hope that helps.